Question 8. Cylinder A is twice as wide as cylinder B but only half the height. What is the relation of the volume? So I can let cylinder A to have a radius of 2 because it's twice as wide as B. Cylinder B will just have a radius of 1. So just trying to pick some easy numbers here. Only half the height of cylinder B. So I'll make the height of cylinder A equals to 1. Because it only has half the height of cylinder B, then the height of cylinder B must be 2. Now I can calculate the volumes. The volume in A is pi r squared, so pi 2 squared times 1, we get 4 pi. The volume is B is pi 1 squared times 2, so we get 2 pi. So I can say that the volume of cylinder A is twice as much two times as much compared to cylinder, so this is cylinder A, to cylinder B. Question 9. Solid metal cylinder with radius 6 and a height of 18 is melted down to form a solid cube. Find the length of the side of the cube to 2 decimal places. So we have a cylinder has a radius of 6 and a height of 18. So we are going to melt this down and then try to make it into a cube. And you want to find the length of the side here. So I can first find the volume of the cylinder, pi r squared, so pi 6 squared times 18. I got 648 pi. And then, now I can say that this volume, the volume of the cube is x to the power 3, just x times x, should equal to 648 pi, because they have the same volume. And now I can just take the cubic root on both sides to find x. And then I would type that into the calculator. Your cubic root button is right here. This one, the orange one or the yellow one. So I just go shift that 6, 4, 8, and then pi. And that will give me the answer, 12.7. 12.67. They want 2 decimal places. So side length of the cube is 12.67 centimeter. Okay, moving on to question 10. Find the volume of a chocolate cake with a diameter of 20 and a height of 6. If the cake is missing a slice whose center angle measures 60. So we have a cake. One of the pieces is missing. So diameter is 20, which means the radius is 10. The height is 6. So the volume is going to be pi r squared. Now the base is not an entire circle, so I need to times it by 300 over 360 because 60 degrees is missing in the entire circle. In the entire circle, there is a 360 degree. So if this is 60, then the remaining part is going to be 300. Right? This is why I still have 300 degree left out of the 360. So this is why I times pi r squared by that to calculate the base area here. Okay, and then times the height. The height is 6. So I get I'll just type this into the calculator. So 10 squared is 100 times 300 over 360 times 6. I get 500 pi cubic centimeter. Of course, I can change this into a decimal too. I get 1570.7 or 8, just 8 cubic centimeter. Cylinder and a rectangular prism have the same volume. Okay. Cylinder and a rectangular prism, they have the same volume. The rectangular prism has a length of 4 pi. The height is the same as the cylinder, so we'll just let that be 1 for simplicity. If the cylinder has a radius of 6, what is the width of the prism? So I'll just let that be x. The volume of the cylinder is pi r squared h, so pi 6 squared h. We should get 36 pi. The volume of the rectangular prism is 4 pi times x times 1, just length times width times 1, and we get 4 pi x. So now I can say that 4 pi x must equal to 36 pi because they are equal in volume. To find x, I can just divide both sides by 4 pi. And I get x equals to 9. Therefore, the width is 9 centimeter because everything is in centimeter in this case. Question 12. The volume of a cylinder is 108 pi. Diameter is half the height. Find the radius of the cylinder. So I'll let the height be 4x. The reason why I let it be 4x is because then the diameter will be 2x, because diameter is half the height. And now I can say that the radius is x. So it's really because I wanted to let the radius be x, that's why I had the height as 4x and the diameter as 2x. Okay, so now I can say that the volume is pi x squared times h. 4 times pi is 4 times pi is 4 pi, x squared times x is x to the power 3. We were told that the volume 4 pi x to the power 3 equals to 108 pi. So to solve for x, I can first divide both sides by 4 pi. We get x to the power 3 equals 45. To find x, we can just cubic root both sides. Because cubic root and raised to the power 3, they cross each other out. We get x equals to the cubic root of 45. So we got 3.6. They didn't give us the unit here, so I'll just say 3.6 units. The radius is 3.6 units. The area of the label on two similar shaped soup cans are 81 pi and 144 pi. How much bigger in volume is the larger can compared to the smaller can? So definitely a math contest kind of problem. You need to know the area is two-dimensional. So the ratio between the area, 81 pi to 144 pi, we can first simplify this. We can divide both sides by 3 pi. So if we do that, we should get 27 to 144 divided by 3, 48. We can divide both of them by 3 again. We get 9 to 16. Okay, so that's area. If you want to go back to length, length is 1-dimensional. So we would just square root the ratio between the area. So we get 3 to 4. Finally, we can go to volume. Volume is 3-dimensional. So from 1-dimensional world, the length, we just need to raise it to the power 3 to get to volume. So the volume, the ratio between the volume is 27 to 64. How much bigger compared to the smaller can? So now we can say that therefore the bigger can is 64 over 27 times bigger than the smaller one. So that's 3.5. Question 13. Yeah, so that's what we have here. So, just playing around with area is 2-dimensional, length is 1-dimensional, and volume is 3-dimensional, you will be able to solve this problem quickly. So if you don't get it, I think it's okay. It's most likely not going to be tested. Okay, moving on to question 14. What effect does each condition have on the volume of a cylinder? So we can let the original cylinder be the most easy one. The most easy one is let the radius be 1 and the height be 1. And then now we can say that the original volume is just pi r squared h. So the volume will just be 1 pi. A, if you double the height, so the radius is still 1 and the height is 2, then now you can find the new volume. Just pi r squared h. We get 2 pi. Compared to the original one is 2 times greater. B, double the radius, so this time radius equals to 2, height is still 1. Volume becomes pi r squared h. You get volume equals to 4 pi. So again, you just compare this with the original one, 4 pi to and 1 pi, the volume is 4 times bigger. C, double both height and radius. So radius equals to 2 now and height equals to 2. Volume is pi r squared h. We get 8 pi. So this is 8 times greater. D, triple the height. So radius is still 1, height is now 3. Volume is just pi r squared h. We get 3 pi, so the volume is 3 times bigger. E, triple the radius, so this time the radius equals to 3 now, and the height is still 1. Volume is pi r squared h, so we get 9 pi, so we can say volume is 9 times bigger. Triple the height and the radius, so radius is 3 and the height is 3. Volume will be pi 3 squared times 3, so we get 27 pi. So we can say the volume is 27 times bigger. Okay, that's the end of 3.5. I'll see you in 3.6.